Alright guys, here we go. This is part 2 for 11-1, simplifying radical expressions. This is the part where we talk about rationalizing the denominator. And all the rationalizing the denominator means is that you are going to get the radical sign out of the denominator. You're not allowed to have a fraction where a square root symbol is in the denominator of the fraction. So just keep that in mind. So let's go through this now. Okay, looking at the first problem, we're going to start out with a simple one here. Again, you need to understand that just like in the last part, when you can say two radicals multiplied together make a bigger radical, so you can multiply radicals together, dividing radicals is the same. So when you have a square root like this, the square root of 49 over 4, you can really think of it as the square root of the top number and the square root of the bottom number. So you're saying I have the square root of 49 being divided by the square root of 4. And in this case, nothing really to do here because they are both perfect squares. This answer just ends up being 7 over 2. Done. Square root of 49 was a perfect square. Square root of 7 was, or square root of 4 was a perfect square. Now, for this next part, we have the square root of 10 over 3. So again, I'm going to look at this and I'm going to say, well, I'm going to change it to the square root of 10 over the square root of 3. Now, since radicals have very similar properties that whole numbers do, the fraction, dealing with the fractions will be the same. If you can simplify a fraction, either right here, 10 over 3, divide them both by the same thing, or right here, square root of 10 over square root of 3, if they could be divisible by the same thing, you would go ahead and reduce it. Same way you would a regular fraction. In this case, though, we don't have that. We can't reduce 10 and 3. So we move on to the next thing, which is everything's fine with this except for the fact that I cannot have this square root appear in the bottom. I'm not allowed to have a square root in the bottom. Simple step here to eliminate that or to get rid of that, and that is to simply multiply the numerator and the denominator by that denominator radical. So I'm going to multiply this problem. I'm going to multiply the numerator and the denominator by the square root of 3. Because I know that multiplying by the same exact square root is going to give me a perfect square. What is the square root of 3 times the square root of 3? Well, it's the square root of 9, which is just going to be 3. So I've eliminated radicals in the bottom by producing a perfect square. Now, what is the square root of 10 times the square root of 3? Well, that's going to be the square root of 30. Now, I'm not done, however. I'm going to go over here, and I'm now going to reduce the square root of 30, and this would be from what we did earlier. I'm going to say square root of 30 breaks down into 3 times 10. 10 breaks down into 2 times 5. Oh, wait. Square root of 30 doesn't break down because there are no pairs, so I actually was done right here. Square root of 30 over 3 is finished. Now, some of you might be thinking, well, why don't I reduce the 3 and the 30 because they're both divisible by 3, but you forget now that this fraction bar, only the numerator is a radical. The denominator is a whole number. Whole numbers and radicals don't mix well together, so do not reduce whole numbers with radicals. Whole numbers with whole numbers reduce, radicals with radicals reduce. Don't cross-reduce them. Alright, number 10 here, kind of talking about what I was saying a minute ago is the square root of 2 and the square root of 6, they are both radicals. They're being divided, and they're both divisible by 2, so I'm going to do that. I'm going to reduce these both by 2, and I now have the square root of 1 over the square root of 3. Well, square root of 1 is nice because square root of 1 is just 1, but I still have this problem of having a radical in the denominator. Square root of 1 over the square root of 3 is not done because I have to rationalize the denominator, and again I do that by just multiplying it by whatever radical's in the denominator. because we should now know that the square root of 3 times the square root of 3 gives me just 3, because it was the square root of 9. And then 1 times the square root of 3 gives me just the square root of 3. And since I cannot reduce the square root of 3, I'm obviously done there. So there's kind of a quick warm-up on it. Obviously there's going to be much more to this, this little part, so let's just move right into it and talk about number 11. Alright, so number 11 here, 4 over the square root of 5. Nothing can cancel because 4 and 5 are 4 is a whole number, 5 is a radical for one thing. The square root of 5 cannot be simplified at all, which again, that's another thing you can do, is simplify your radical first. So in this case, all I'm left with is rationalizing the denominator, meaning get rid of this square root in the denominator. I'm going to do that by multiplying both numerator and denominator by the square root of 5. Again, square root of 5 times square root of 5 is, yes, technically the square root of 25, but you should just now know that that's just going to be 5. And then the numerator, you have 4 root 5. You do want to check to see if whole numbers can reduce. 4 and 5 are both now whole numbers, but since they do not reduce, and you don't have any other radicals to reduce the square root of 5, you are done. Not too difficult, right? Alright, go ahead and try number 12 maybe on your own by pausing the video. But I'm going to just keep moving along. Any of these that you want to try on your own before I just show you how to do it, just pause the video. Attempt it out on your own. Try to learn this on your own. Try to figure it out. And then I'll just come around and when you unpause the video, explain how to do the problem. So with the square root of 8 over the square root of t over the square root of 8, there's actually 2 different ways to do this problem, and I'm going to go ahead and show the second way down here. So square root of t over square root of 8. First way here, obviously just rationalize the denominator. Multiply both the numerator and denominator by the square root of 8. That's going to give you, the denominator is just going to be 8, because it would have been the square root of 64, which we know is just 8. And in the numerator, again, those multiply together, so you just have the square root of 8t. Now, the problem with this is that the square root of 8t, the 8 part of it can be reduced. So you're going to reduce the square root of 8 like we have before. I'm going to just do this over here in this empty space. 2 times 4. 4 is 2 times 2. So a pair of 2's comes out and a 2 stays on the inside. So you got a 2 on the outside, a 2 on the inside. The t to the first power stays on the inside, and you have a denominator of 8. Well, as I said, whole numbers cancel. Go ahead and cancel them. So now I have 1 square root of 2t all over 4. And again, do you have to write that 1? No, you don't have to. So just 2 root t over 4 would be your final answer there. Now, the other way to go about that, same problem, is to first simplify the square root of 8. We're not going to go through the work here because obviously we know already that the square root of 8 turns into 2 root 2. And now, and again, this is a different way to do the same problem, so I'll draw a line here to separate the two. Now with this problem, rationalizing the denominator means all I have to do is multiply by square root of 2. And we haven't actually done one like this, so let's look at this. Multiplying top and bottom by the square root of 2. In the denominator, yes, the square root of 2 times the square root of 2 gives you the square root of 4, and yes, that just turns into a 2, but don't forget you had this other whole number 2 that was already down there. So I end up with 2 times 2 in the denominator. In the numerator, you have the square root of 2t, which again just gives us our final answer here of the square root of 2t over 4, which is what we got the other way. So again, really you have a lot of choices here. Simplify, cancel, reduce, first, last, both. Just always get it down to simplest form. So we're looking at number 13. The way I'm going to go about doing this is I'm going to reduce everything that I can underneath the radical before I even start the problem, meaning that 9 and 12 both reduce. They're both divisible by 3. So that's going to turn into, and I'm going to just rewrite this problem below it. Do a big square root sign here and a big fraction bar. This is going to turn into 3 and 4, right? Because they're both divisible by 3. Now again, remembering some past knowledge, x to the 5th and x to the 2nd, this was not necessarily something a lot of us were great at. How does this reduce? Well, you had 5 x's in the top, 2 x's in the bottom. So how many of them can cancel? 2 of them, leaving you with 3 x's in the numerator. So x to the 3rd in the numerator. Y's kind of work in the reverse order. There are 2 in the top and 6 in the bottom. So I'm going to cancel 2 of them, leaving me with 4 in the bottom. Or you might remember this method as like the subtraction method. For the x's, you have 5 minus 2. You have 5 minus 2. 5 minus 2 is 3, so x to the 3rd is in the numerator, which you have. And then the y's, 2 minus 6 is negative 4, and that's why this y went down to the denominator as a positive 4 in the denominator, because it was negative originally. So, a couple ways to go about it there. Next thing here is to simplify any farther that you can, or take care of any problems that you may have. First thing you should notice here is my denominator. I'm not going to have to worry about rationalizing it, because isn't that a perfect square? Yeah, the square root of 4 is just a 2, and what's the square root of y to the 4th? Well, that's just y squared. Numerator stays the square root of 3x to the 3rd. Well, stays that temporarily. Because you say, well, the square root of 3 cannot be reduced, but can the square root of x to the 3rd? And yes, it can. X to the 3rd, again, hopefully you're thinking of it as x squared and x, meaning those two x's pair and come out. So we have x on the outside, square root of 3 with that x on the inside, and then 2y squared. So, there you go. That's how you reduce that problem. Kind of a few steps there, but once you get the hang of it, this is really a pretty easy section. Number 14, let's go right into it. Again, I'm going to reduce this as I go. I'm going to do everything on the inside first. So again, here's my big fraction bar. 5 and 10 become 1 and 2. B to the 5th and b to the 6th. That's going to leave you with 1b in the denominator, and then c to the 6th still on the top. So I'm going to take care of a few things. For instance, here I know I have perfect squares in the numerator. Square root of 1 is 1, and then square root of c to the 6th is c to the 3rd. So my numerator is